Hello and welcome to the Engineers Australia Spring Forward webinar series. I'm your host Andrew Grill, a former engineer from Australia and now the actionable futurist based here in London. In this series we'll hear from some of the world's foremost engineering companies about their products, what makes them so special, and how engineers can solve almost any problem imaginable. At the end of our discussion today, you'll have the ability to ask any question you want. Please submit them at any time using the chat function in the Zoom app. I'm delighted to announce our first guest for the series, Professor David Keene, CEO of autonomous vehicle company Aurrigo. Welcome, Professor Keene.
Good morning from rainy England.
David, it's so great to have you on the very first of our series. I've been wanting to talk to you for a while because this is an area that I'm really interested in. But let's give you the floor. When we hear about autonomous vehicles, many of us think about driverless cars. You've actually developed some autonomous vehicles for a range of different industries. How did you start Aurrigo, and what are the problems you're solving?
Well, I guess starting Aurrigo goes a little bit further back when I started the first core automotive company. So that was back in 1993. So I used to work for Rover Cars and Jaguar Land Rover and then BMW, and I took voluntary redundancy in 93, 94. And so I'm the classic story of my little bedroom through to what we have today. So I sat for 9 months doing that. And then today we've got what I call probably one of the most advanced technology companies, certainly in the UK, and maybe potentially, in the top 10 around the world. And I guess we've always been a technology company. So our technology has been predominantly for the automotive industry over that 28-year period. But 8 years ago, I decided, foolishly or not, that we got so much technology within the building and within the team that we were going to move into autonomous vehicles. And that started out with a government program where we were asked to come up with a vehicle platform, and then quite quickly I hired a team of software engineers and specifically to do the autonomous control system software. And what you're seeing here today on this video is the culmination of that sort of 8-year period that we've had. This is a project that we've got in Cambridge in the UK, and we've got 3 of these autonomous shuttles. They carry 10 people. They can be run as a conventional EV, which sets us apart from most of the other competitors. In fact, there isn't a competitor in the world currently that you can drive it as a standard EV or you can run it in autonomous mode. We've got 3 of these vehicles in Cambridge. We're coming to the end of the project in Cambridge, which has been, to be honest with you, absolutely amazing. So this is a 3-year government-funded through Innovate and CCAV in the UK, and I'm not sure whether your viewers and listeners know about that. But certainly the UK government has been, over the past 6 or 7 years, very strong in providing funding for companies like ours, and they've put hundreds of millions into supporting this fledgling technology. And so those vehicles are currently running as we speak, and they're actually taking real passengers, and they're running live in real traffic. So although there's still a safety supervisor on board, and maybe later in this discussion we can talk about how you get rid of a safety supervisor, because otherwise it'd be pointless to have an autonomous vehicle. It's certainly a major step forward in bringing those vehicles to do a real job in society.
So obviously test and trial is so important, but what are some of the obstacles you've overcome along the way in getting from a prototype to actually getting this on the road and having people allowed to sit in it?
That's a really good question, and to be honest with you, I could probably talk for about a day and a half on the amount of things we've had to solve. Honestly,
Yeah.
it is a hugely complex thing. I'm a techie guy, so I like launching into things and doing stuff that other people might not have done, but I can tell you this has been and continues to be one of the most challenging things I've ever done in my life, and also my team. There is everything. I mean, first of all, you've got to get a very stable and safe vehicle drive-by-wire platform. Forget the autonomous driving. When you're steering by wire, braking by wire, and all of your drivetrain is by wire, and all of your sensors set then has to be held on that structure pretty perfectly. And then, of
For
course,
those that don't understand by wire, you might just
oh
explain
yeah,
that some who aren't engineers, they might have flown in an Airbus plane, which they now command with a joystick, which is fly by wire. What's
yeah.
that technology, and how is it different from the old pulley system?
Yeah, so on a conventional vehicle, for instance, you're steering with a steering wheel, which is in most cases directly connected through a column into the steering rack that is then connected to the wheels. So that's pretty much all a mechanical system, and then that went through to an assisted system. So you get driver assist. Some of that was pneumatic systems, or whether that was electrical systems, and then eventually that was disconnected completely. So the steering wheel does not mechanically connect to any of the steering system at all. It's basically connected through a wire into a control unit, and that electronic control unit then controls a motor that steers the vehicle, and so forth. Same with braking. When you press the brake pedal, you don't have a hydraulic system connected to that brake pedal. That brake pedal is electronically wired to a control unit that then controls the hydraulics. So you can imagine that setting up that base platform to be absolutely 100% secure all the time, because it's complicated enough doing the autonomous control software. What you don't want is a base platform that is shaky. It's got to be 100% perfect. So I guess our automotive background over 28 years of doing really high-tech, safety-critical systems for the leading vehicle OEMs has meant we can develop that platform. And as you said in your intro, we've developed multiple platforms, whether they're passenger vehicles, and we'll probably in this session go on to talk about what we're doing at airports, but they're all the same. You've got to have a 100% rock solid platform, and then you bring that autonomous system and the clever bit on top of it, really.
Now, we're a couple of geeks, so we could geek out all morning, all evening about the
Yeah,
technology. I want to just move on to some of the business things. So,
yeah,
this week in London, we signed the Australia-UK trade deal, a humongous event there with Boris Johnson and our Prime Minister Scott Morrison.
yeah.
So, what does that deal mean for you and further deals? How are trade deals helping? And I understand you had some issues earlier on getting vehicles into Australia. They classified them as luxury vehicles. Tell me how you overcame that problem.
Yeah, they did. So just to take the first bit, I mean, signing that trade deal, that is the first proper trade deal that we've really done. All of the rest of the deals, although they're great, they've been pretty much rollover deals. So for the UK, that is a major stepping stone, because it proves that life outside of Europe, we can do deals, and they're important deals. We've got a long history of association between the UK and Australia, and I'd say. We're talked about as cousins, but I think we're actually brothers. I think it's
Oh,
brothers
very
and
much so.
sisters. And you're right. There have been some complexities, and anything about new technology is always worrying, because people who are doing a really good job in any country where they're trying to control imports, they're trying to work out tariffs, they're trying to classify things. If you're moving a sheep, from one country to another, what a sheep looks like, and that sheep has
Yes.
been in existence for hundreds of years. You turn up with an autonomous vehicle that doesn't look like anything that anyone's ever seen before, and that is a real problem, because those really good guys and girls who are trying to classify these things and work out how you do it are just faced with something that's impossible. They don't have a rule book that tells them what it is. So what they did was they asked me, how much is the value of this vehicle? And I said, well, it's £500,000 was the first vehicle. And we shipped 3 of those, so 1.5
Right.
million pounds. And the only rule book they'd got was £500,000 means that must be a luxury vehicle.
Luxury.
So therefore, here's, I forget now, but I think it was something in the region of $100,000 import tax per
Wow.
vehicle. So they were impounded, and the only way we could get them out, I mean, we obviously argued, look, this is new tech, this is new vehicles, they're
Yeah.
coming over here to do a project. The only way we could do them, to get them out, is to actually pay the money. So we paid the money over, and then over a period of about 6 months, we negotiated, and eventually we got that money paid back, because there was a recognition, obviously, that these vehicles needed to come into the country. And so it took nearly 6 months to work out the paperwork, which is an interesting thing, because when you're a relatively small company like us, and you're faced with a 300,000 import tax bill that you weren't expecting,
Yeah,
that's quite a
that's
shock.
tough.
So coming back
Yeah.
to the why is the trade deal good, is because actually, whether you're moving lamb or beef around, or whether you're moving autonomous vehicles around, to have that seamless relationship is something really good, and obviously fosters new business. And that's what this is. It's all about what can Australia do trade-wise in the UK, and what can UK do in Australia. And I know there's rumbles, about, oh, it'll affect this market and that market, but fundamentally that is a great deal. And the UK is now literally going around the world trying to sign up these deals. It's a real new era for us, and I think most people in the UK see this as a really positive thing. So we look forward to more deals with companies and organisations in Australia, definitely.
And that gives you an on-ramp for Australia and other companies. Are you able to partner with the government to? I know that there's a lot of Great Britain logos on the vehicles. The UK government have obviously want to promote this as world-leading technology around the world.
Yeah, exactly. So we have a fantastic relationship with the UK government. In fact, we are the poster boys for the poster company for the Great campaign in the
Mm.
UK. So you'll find that whenever you go onto the Great website, or you look at anything that the Great campaign pushes out, more often than not, there's one of our vehicles wrapped in a Union Jack with those logos on it, because it is, first of all, exciting technology, newsworthy. The amount of PR and press we get
Yeah.
coverage on it. So from the government's point of view, that's great. But it also shows, look at the technology that the country is able to develop. And not only on the export, but it's all about as well, why don't you come to the UK, whether you're
Mm.
an engineer or whether you're a company, because it's quite a good playing field. It's a great sandpit for. I mean, we've probably got the most autonomous test areas in a country around the world, and that enables companies to come here and do very low, I'd say low cost, low overhead in terms of complexity testing in the UK. And of course, for engineers, the ability for an engineer to come to the UK and work here, is only going to get better in the future. So all of those things are really great for the UK, and particularly now, export is a really big thing for the UK government, to show that we can export, and that actually there are markets beyond the EU, even though the EU is a really important market for us. So we're not dismissing that in any way.
So you talk about engineers and talent. Are you in a war for talent? Are you able to find the engineers you need? And you've got the platform now. Who are you looking for, and who should contact you if they're an engineer out there that's looking to either move countries or move jobs?
Yeah, so engineering talent is thin on the ground, I have to say. And we're struggling to find people for the expansion that we're doing, and there are some factors beyond our control. It's not just about education, and people say, oh, we haven't got the engineers coming through that we used to. There's some other factors. The COVID crisis has, in our view, caused quite a big problem. I'm of a generation where, everybody works to 65, and then you retire, and that's it. So I'm 57 now, and quite a lot of my friends and people that I've known and I've grown up with in the industry, between the age of 50 and say 60, they've decided to retire. Or if not, they've retired and taken a very low level job. So, for
Mm.
instance, they've started working at a supermarket, moving the trolleys around in the car park.
Mm.
So, I
Mm.
kid you not, I've got friends of mine who are first class engineers who have retired and are doing part-time jobs. And one of the things that has brought is this COVID problem has meant that people have really reassessed their lives, and
Mm.
the fact that you might die of this thing. Particularly, we've had it really bad in the UK. I know you've done some superb lockdowns and control in Australia, but in the UK, I personally have experienced it in that I've had COVID myself. One of the
Yeah.
ladies that worked for me in the production area, unfortunately, she died in in
Oh
uh,
goodness.
in March of last year. So it's been a real big mental and social thing here. And what that's done is, when you're a younger engineer, I remember when I started at Rover, how did I learn all of my post-degree stuff? I learnt it off the people that were there. And most of those people I learnt it from were in their 50s and their 60s. And now, if those are disappearing, I'm not quite sure what happens now to younger engineers who come through, because they've lost that mentor. So we're finding that more and more in the UK. So the only thing really that we're doing and the other thing that's combating that as well is less people, more companies springing up. Lots of those companies very well funded, and those companies are then saying, well, to get that girl or that guy, we need to pay them more money. And so we've seen a very, very fast ratcheting of the salary expectations. So there's a lot of forces that are beyond our control. But one of the ways we've combated it is we've struck up relationships over many years now with the local universities. So what we try to do is we try to get the best students who are coming through, say Warwick University, Coventry University, Aston University, and then grab those because they're bright, they're into computing and electronics. And then what we're doing as sort of older hands is doing that mentor bit. So we're mentoring them inside the company. And that's the only way we've been really able to get the staff that we've got. And actually, we now have quite a young group of engineers who, to be honest with you, are absolutely exceptional. And we have an Australian engineer. We've had several Australian engineers come over and first of all do work experience with us, and then we've said, blimey, these guys and girls are fantastic, and we've kept them, and they're working here today in the UK. So we're looking for anybody who's got software, electronics, automotive experience, but more than anything, we want somebody who will fit into a fast-moving team, who really will take on responsibility, who's really hungry to work on this new technology. And those people are there, they just need molding a little bit. So, long answer to a short question. Sorry, Andrew.
No, it's great. Now, related question, and we always talk about COVID and the impacts of that and remote working. And I suppose for some companies, remote working is easy to do. If you are in a manufacturing organisation, you need people to physically turn screwdrivers and solder things. But you made an interesting point there, and certainly about young engineers and mentoring. Talk to me about how your company is evolving in a distributed workforce, and when we're mandated to work from home, how do you get work done? And when you need people to mentor people, how's that best done, and how are you adapting in this remote distributed environment?
Yeah, another great question. Well, I also come from a background that says you turn up at 8:30 in the morning, you always go to work, you work till whatever time and you go home. So you're always in the office with colleagues. And occasionally, we're a very flexible company. You know, if someone says, I've got a problem, I can't come into the office today, I'll work from home. Of course, we're very flexible in that regard. But 99 times out of 100, all of my people have all been on site, have all been working together until the 24th of March last year, when we were just told, you need to shut immediately. And since that time, that has been transformational for us, because we've been quite shocked as to how much we've been able to do without people being in the office. Now, you're right, we've got a manufacturing part of the business, and it's very difficult to individually manufacture stuff at home. You know, that's never going to work. But if you look at other areas of the business, we've very successfully worked at home. And the other thing that's really struck us as well is prior to COVID lockdown, I mean, I was traveling with my colleagues all over the world, meeting after meeting, flight after flight, all going around. And again, what would we have done 10 or 15 years ago without Zoom or without Teams or without these platforms? And what that's done is enable us to conduct business without going anywhere. Now, of course, there's still that personal element of building, personal relationships that you really need to go and have a meal, go and have a beer with somebody, cement those relationships. But I can tell you, I'll give you a practical example. We won a piece of business in February of last year in Singapore, our first two contracts actually in Singapore. And since that time, we have not been to Singapore at all. So even today, we haven't been there over that period. And we have completed both of those pieces of work completely remotely with both the Singapore teams and the UK teams working together to do that. And not one person has travelled either way. And it just shows you how actually if there's one thing humans do is they can adapt. And so what I think we'll see in the future is we'll go back a little bit to that working in the office, but actually we will be a lot more fluid and a lot more receptive to changes. And when someone says I'm working from home, an old guy like me, doesn't say, hang on a second, you need to be in the office. They look at that and they think, probably I'll get more out of them if they work at home than when they're in the office. And we've seen that as well. We've seen levels of productivity increase because people are working at home. So although we've gone through a very sad and difficult period and we continue to struggle to get out of this COVID problem, actually, there are some good things and there are some things that we will definitely continue to use. And there's no way we would have done those if we hadn't have had that COVID.
I've probably spoken to 50 people like yourself on my podcast and other webinars throughout the year, and they're all saying the same. And I think it's not just humans adapt. I'm an engineer, so of course I would say this. I think engineers are trained to think in a different way. I was an engineer that then moved into marketing and sales and general management, but I've always been trained from first principles of how to solve a problem. Do you think the way we as engineers are trained makes us more adaptable to when something like a curveball of COVID is thrown at us?
Yeah, I think that first principles, again, I think as well, Andrew, that's a generational thing because I certainly know that, the kids and students and what have you that are coming through the educational system at the moment, they're not taught first principles, how I was taught first principles. And therefore their ability to go right back to first principles to allow them to think clearly about how they would solve something, I think is lost in that generation. I certainly think I can see that across my workforce. In fact, my younger people are far more agitated about the situation we have currently than the older people are. The older people have sort of got on and done it and worked out how to do it. Our younger people are far more, they need a little bit more cotton wool just to hold them together and to explain how we might do stuff. Certainly, if we talk about pure engineering, when we look at problems, there's certain of us who can break that right the way down to first principles, and even to the point where you get a gut feel over something. You go, that doesn't look right. If you did that and that on something else, it wouldn't produce that. And that doesn't happen in some of the younger generation. They've got nothing to relate that to. I'm not saying they're bad because actually they've got some fantastic skills that I just don't have, and that's why we've got them. But certainly, first principle engineering, as I was taught, technical drawing, metalwork, woodwork, right back to can I hold a file and can I file a piece of metal? Or can I scribe a line? Real basic stuff, and then the basic stuff of mechanics in terms of linkages and how does all those sort of things work. I think it's a lost generation, personally.
Well, I remember being drummed into me. So I'm an electronic engineer, and I remember one particular instance when we were preparing for practical work, and it was Gunnar Creeves. If you're listening out there, Gunnar, thank you, because he forced us to do pre-work. He said, if you're going to do this experiment, I want you to know what the answer should be. So should it be 5 volts or 7 volts? And it annoyed the heck out of me. Why do we have to do this pre-work? Why can't we just go in and do it? And he taught me that you need to understand what to expect. So when we went in there and it was 12 volts, he said, well, your pre-work said 5 and you've got 12, so something's wrong. And
Yeah.
that has held me. It's probably 35, 40 years ago that happened. And when I have friends saying, oh, my internet's down or it doesn't work, and I say, I'm going back to first principles, they go, what does that mean? So I think it is a lost art. And I
Yeah.
think business people could do well to learn about how engineers think. But of course, we would say that on an Engineers Australia Spring Forward webinar. Now,
Yeah.
this is a first webinar we've done. I want to break some news here. We're gonna tell you something that no one else has heard before, and I've got your permission to talk about this. Very excited.
Sure.
You've just done a UK-wide deal with Vodafone and AWS. Now,
Yeah.
I'm going to roll some footage over the top of this so you can talk about what it is that you've done. But this is huge. Edge
Yeah.
computing, 5G with AWS. Tell us all about it.
Yeah, so fundamental problem currently with autonomous vehicles is how do you get the safety supervisor out of the vehicle, and how do you run the vehicle then in the most safe and secure way? And what you really need, amongst all the other things, is you need low latency, high bandwidth, what's called edge computing. And what that means is, at the moment, we're running these vehicles that you can see here. These are running on the road in Cambridge. And we're transferring data and receiving data from a server that's basically web-based. And although we try and spin up a server over the country that we're operating in, we've got a latency time on that shuttle between us and our back-end system of about 80 milliseconds. And that's too long. I mean, it's fast, but it's too long. So what we really need to do is we need to move that server to a location which is the shortest distance away from where we're operating. So what we've done with AWS and Vodafone is we now have the AWS server actually at the mast. So the 5G mast is in Cambridge, or there's several of them. The AWS servers are actually located there, and it's called MEC, which is multi-access edge computing. And this is the first practical example with our shuttles outside of the US that AWS has done. And of course, this is all on the 5G network from Vodafone. And what that's done is it's pulled our latency time down to about 20 milliseconds. And now what that means is, because we've got that ultra low latency and high bandwidth, by the way, it's called the AWS wavelength system, if you want to look it up. And today, if any of your engineers or viewers or whatever just go onto the AWS website, you can, and Vodafone website, you can see just search for this, and you can read all about it. It's been launched, and what that means now is we can now take the safety supervisor out of the vehicle, and we could use the remote supervision to monitor all of our vehicles, and monitor not just 3 vehicles, but 300 vehicles or 3,000 vehicles. So although we're not at the point where we're monitoring 3,000 vehicles, this is a critical step in the next stage to bring fully autonomous, no safety supervisor vehicles into our environment to actually do practical jobs, and to make sure that we've got low latency communication, which enables us to be safe and secure. So if we want to stop one of these vehicles, that's the low latency connection we've got.
And it's fair to say the whole 5G standard, whenever I'm asked about, well, what's the promise of 5G, it's not just speed, but it's the architecture of allowing you to have a server in the base station. Those that are telecommunications engineers will know that there's a mast, and at the bottom of that is the control head, and you've got the transmitters. But now there's space in there for an AWS server. This is a fundamental shift in how mobile networks operate, and this is a great use case to explain that.
Yeah, so these 3 shuttles in Cambridge that you can see on the video, they're all on that system. They're all operating. It's the first practical example, and obviously what we're doing, and what I mean, this is a big thing for AWS and Vodafone. It's a huge thing for us. You know, first of all, to be associated with those 2 brands, and to be the first company to work with them on this. What will be? It's a global problem. It's a global problem, and we're one of the first, working on this. So we're extremely honoured and pleased to be here. And of course, as far as Vodafone and AWS are concerned, how many companies are running autonomous vehicles around? Not many. So actually, it's a really good opportunity for them to work with a company like us to hone this system, so that eventually, in short space of time, we can roll this out. Well, certainly UK wide. Vodafone and AWS have a plan to roll this out UK wide in very short time.
Now, we've had some questions come in from the audience. I'm going to read a couple out now because I
Yeah,
think
sure.
they're quite relevant. Elizabeth Harrison asks, critical thinking and holistic thinking with engineering. I was talking to another engineer today about these topics. Can you elaborate on how these contribute to engineering and providing solutions to the community from your perspective?
Well, that's a really good question, isn't
Thanks,
it?
Elizabeth.
Yeah, that's quite a complicated question because it depends how you define engineering. Engineering is so wide. So you take our autonomous vehicles, for instance. We've got real pure engineering. I mean, engineering that cannot be done by multiple people because you need a specific person working on a problem. Say, for instance, working out image recognition. That is a very tight, classifying, is that a dog? Is that a cat? Is that a bicycle? And trying to work out that from a very pure stuff. And at the other end, we've got engineers working out how do we make sure that that vehicle, when a blind person or a person with a guide dog is able to access that vehicle and know that they're safe to get in, they're safe how they're seated, they can get all the information that they want, and actually they know where they are, and they can get in and out of that vehicle and be confident. So our
Yeah.
engineering team, which is, I mean, it's minuscule compared to the Googles and the Ubers of this world. My team are having to cope with those wide-ranging engineering skills and problem solving, and I guess there's a time and a place for somebody who's super dedicated, rifle shot focused, and then there's other softer aspects of engineering, and I think the word engineer covers so many things. It's an amazing word, really, because if you actually listed out how many things an engineer actually does, it would be mind-boggling. I'm sure if we whiteboarded it, we'd probably have over a thousand
Yeah.
things that an engineer does. So that's what's exciting for me, by the way, and part of that question. We're not just working on one thing, we're working on all of these things. And I think coming back to what we can give to people, particularly younger people coming through, I don't think there's many places and many companies where a younger engineer could be exposed to the wide remit of what we're doing on these vehicles and these systems. I know myself because I take a step back every day and I look at what we're doing, and I always think to myself, well, it'll take a lot to impress me these days because I've seen quite a lot. And I look at what we're doing every day, and even I'm impressed. I just think, wow, isn't that great? And and I just think how I would have felt when I was in my early 20s if I'd been parachuted into our company. Boy, oh boy, I would have been absolutely so excited. I mean, it's just amazing.
Another question from James Bunn. Many of our members are civil engineers and design, build, and maintain roads and highways.
Yeah.
It seems to me that your vehicles will standardise the wear and tear on their infrastructure. Do you believe that applications such as the Cambridge Park and Ride will provide data to help you present a case to public authorities? Great question.
Yeah, so I think I can answer that splitting it into two. So anybody who's currently working in, I'll use the word infrastructure rather than sort of civil engineering, but certainly infrastructure. Those guys and girls have a massive role to play. This is a huge jigsaw puzzle, and we're just one bit of it. And I've talked about another bit of it, which is communication, the AWS Vodafone bit, and how do you do all the comms. But there's all these bits of jigsaw puzzle, and until they all come together, we won't have a solution. And certainly, infrastructure is an area where we need to work out what infrastructure we need, what changes, and also what are we going to agree now to build into the future, and how we're going to do that. So I'd say whether you're in computing or electronics at one end or you're in civils at the other end, all of those disciplines are going to play an important part of what we're doing. And I think it's important to think that we've got that whole that whole jigsaw puzzle and to think about how big this problem is. So no one company like us or like a Vodafone or an AWS is going to solve this. So there is a lot of coming together, and that's actually a challenge for the industry, because it's multiple industries under an
Yes.
industry. And I also think it's a huge challenge for governments, because if you're a government, the UK government is currently struggling with this. They're trying to work out where do they put all their money, and the answer is you've got to put your money into a lot of different things, and you've got to coordinate that. Tell me James's second part of his question, because I've just forgotten, because
It's about wear and
I've been on
tear.
about
So
that.
if you,
Oh yeah,
yeah, but if wear and tear, because you know what's going on, and the vehicles are somewhat standard. They're not like humans that make silly decisions and rev engines. The standardization of wear and tear, and going back to government saying if we all had autonomous vehicles, there'd be less wear and tear on the infrastructure.
yeah, certainly, and less infrastructure. That's what we've got to remember now. I mean, if we could flick a switch like that, we wouldn't need traffic lights, for
I know.
instance.
Yes, I talk about that all the time. Yeah.
We wouldn't need somebody painting on the ground, a 30-mile-an-hour sign. We wouldn't need a lot of this stuff. So the problem we've got is, it's all right, guys like us, inventing these autonomous vehicles. But in the UK, we have 60 million conventional vehicles. And the problem is that the changeover from autonomous, from manual vehicles, conventionally driven vehicles, through to autonomous vehicles. And that is not going to happen next Tuesday. That's going to be, several generations as we move forward. So that's also a problem for planners. Are you in your area that you're planning for 5 years' time? Are you really going to plan it with no traffic lights? I mean, that's a serious problem, because
Yeah. Yeah.
nobody right here and now would do that, would they? They'd say, well, we're never going to be there. So the point is, when does somebody actually take the decision to do planning without certain infrastructure or additional infrastructure that we don't have today to enable this? And if you think about the planners, they're planning 10, 20, maybe even 30 years ahead. So 30 years from now, there'll be significant autonomous vehicles running around, and with probably the wrong infrastructure. So that's really an interesting dilemma, and I don't have an answer for it. But certainly, upkeep of the infrastructure in the future will be a lot less, a lot less.
So, a related question: you design autonomous vehicles, and like I said in my introduction, when you think of autonomous vehicles, you think driverless cars and Tesla. Why did you go down the path you've done to look at autonomous vehicles that carry people? And I'm going to overlay some footage in a minute about what you're doing with British Airways. But
Yeah.
why did you take that approach?
Okay, so there's a few reasons to it. One, we don't have a multi-billion-pound budget.
Yep.
And if you're a car company, you need billions and billions of dollars, because a car running at 70 miles an hour, say down a motorway, with another car running in the opposite direction at 70 miles an hour, 140 mile an hour closing speed, you need some very sophisticated compute platform to make the calculations in the time. So to run at high speed in a
Yes.
completely open environment is a huge challenge, and one that will take decades. I mean, there's a load of hype in the industry. It'll take decades. But how do you bring autonomous technology, though, to something that you could do today? And so that's what I looked at. And I thought, well, we haven't got billions of dollars, so why don't we focus on some areas where actually we could make a big change? There's a business case for it. And there's two key critical components. One is it's lower speed. And two, the operational domain is completely defined and much more tightly controlled. So what you're looking at here is our autonomous baggage dolly. And we have developed this. So this is conventional. So a tug, everyone's seen this looking out the window of the plane. A conventional tug pulling manual dollies around. Very inefficient. 60 years in the making, never changed. First thing we did was we took a conventional dolly and we changed it to a drive-by-wire platform, and we put our autonomous control system on the top of it. And that's what you can see in this shot. So that is not an optimum solution. And what you're seeing here is us running live at Terminal 5 at Heathrow.
Mm.
We ran this for a year and really successful. And I tell you, Andrew, the business case for this saves tens of millions of dollars per
I'm
annum
sure.
for the big airports around the world and for also the medium airports. And what you're seeing here is the ability to move baggage and cargo around in a super efficient way. So if you think about this now, you've got a fleet of these. So think of Utopia. You've got a fleet of these running around. We have an AI sophisticated platform over the top that runs these, that optimizes where they go at any minute of the day against a flight schedule. There's a big reduction in health and safety, of course, because these things are running around. They've got 360 views, so they're not running into each other. The reason that platform that we converted there, you can see in the shot, is over a ton in weight originally, is because currently it's been driven into things. So when they drive it into a baggage hall to line it with the baggage lateral, they just drive it and smash it into the lateral and use the lateral to realign all the baggage behind it. So autonomous vehicles don't need to crash, do they? So what we've done, which you haven't seen on here, is we've now built if you go onto our website aurrigo.com, you can see the brand new ground up, I call it super dolly of the future.
It looks very sexy, yeah.
We now have live projects around the world with that, and so implementation of that at scale. We're talking mid next year now. Same with our passenger vehicles. You saw some shots there. The same with our shuttles or our four-seater smaller vehicles. The thing that really defines them is low speed, more defined, controlled environments to operate. And that's how you get autonomy into practical applications that actually solve a need and have a business case around them. And that's what's lacking at the moment with vehicles. They're very complex to do. They're running at much higher speeds. The environment is totally uncontrolled, and we know that as humans. It just shows you how good we are as humans, doesn't it? If you think anyone who drove home tonight in Australia or drove to work this morning in the UK, I bet you, other than if you had an incident, I bet you can't remember how you drove in. I bet you can't remember anything you did. Because
just autopilot.
Humans are so fabulous, and I always say we have a rating on our vehicle, so we have a human level on our control system. So it's probably about the age, I don't know, 8 or 10-year-old. And someone says to me, "Well, yeah, how do you get an 8 or 10-year-old then up to maybe a 25-year-old?" I mean, we all know we pass a test when we're maybe 17 or 18, let's say. And by the time you're 25, you've seen snow, ice, heavy traffic, fog. You've seen all of these different things. So how do you turn an 8-year-old into a 25-year-old, software-wise? And that's the challenge. And will it take, 10, 15 years to do that? The answer is it won't, because my 8-year-old driving system currently will be a 15-year-old driving system next year. And then it will be a 20-year-old driving system the year after that. And that's the speed of the technology. And I think it's always good to think, when someone says, "Oh, well, how capable is your system?" I always try to express it simply in, we've got an 8 or a 10-year-old behind the wheel. And therefore, would you let your 8 or 10-year-old drive at 70 miles an hour? No, you wouldn't. You might let him drive or her drive at 5 miles an hour in a controlled environment. So that's how I position things.
I'm having visions now of your vehicles driving around with L&P plates on the back.
Well, we are in that world currently. We are in that world.
Yeah.
We're in the world of training and observing and learning. The difference is we can learn faster than a human can. A human over that experience. So we don't learn everything practically by deploying vehicles into environment. So we learn a lot through simulation. So of course we have a lot of digital twinning going on.
Yes,
so
of
we're
course.
doing thousands and thousands of calculations and scenario work, every minute here at the headquarters in Coventry, and things that we learn in the practical domain, we feed that back into the digital. Whether that's good or bad, we feed that back and say, well, why did that happen? And run that scenario until we've worked out, okay, we know what that is. But moving, that's a little segue, I guess, into safety. What we don't do is we don't experiment on our customers. That for me as an engineer is an absolute no-no. And that was drummed into me in the automotive world. Although there are some people in the automotive world that like to experiment currently on their customers. We come from a solid automotive background, an ISO 26262 background. So we're designing everything with super high quality and safety in mind. And another key partner for us is Thales. Probably your viewers and listeners will be aware that Thales is one of the global players in cybersecurity and high risk systems, even to the point where our current systems have been evaluated by Thales in terms of their cybersecurity level and how we build those and operate those. Every time we go anywhere, by the way, and we do a deployment, I've got something like an 80-page safety document before we even get there with the vehicles. We've walked around, we've looked at the threats, we've looked at the mitigation of those threats, we've built that safety case. We've even had a third party review that safety case and sign it off. So if you look at that Cambridge video that you were showing there, that has all been gone through that even before the vehicles turn up. So we haven't just invented some autonomous vehicles and got a few software guys and thought, fantastic, let's just bung this in. It's done very from ground up principles to make sure we're doing the right thing at the right time.
Yeah, you've answered one of my questions about cybersecurity. So there's physical security, you don't want them to crash into people, but there could be a catastrophic loss if these are hacked. And given they're running on 5G, and they're, my view is that never expect you're not going to get hacked. Assume you are going to. So what could happen? But talk to me about what would happen globally if these systems got hacked. What are the safety features that override a hacking incident?
Yeah. So that's a good point. Never think you're unhackable. And also, never tell anybody globally that you're unhackable, because the first thing that everyone does is try and hack you.
Yeah.
But you have to start off by saying we are going to get hacked. So back to first principles. Let's look at everything we need to do from a design upwards to make sure that the end result, the attack window for that end result, is as minimal as possible. And that's what we've done. We started with nothing and built that to make sure the attack window was tiny. Each vehicle, obviously I can't tell you exactly because I'll be broadcasting exactly how our cybersecurity system works, but
do not
suffice
do that,
suffice it to say, there is no attack window to take out a fleet of our vehicles. You would have to attack them one at a time,
right.
And to attack them one at a time would take a long time to do. And the other thing that we've done in our structure is that we don't actually send any critical data from our back end to our vehicles. The vehicles are very dependent on themselves. So the information...
Well, that's the word autonomous. They have to be able to be autonomous.
Exactly. They're built so that you cannot drive them remotely. So from our base station, you cannot tell that vehicle to steer left, right, brake. The only thing you can do on braking is emergency stop.
Stop, yeah.
Okay, so you can do stop, but you can't make it go, and you can't do anything like that currently. And that window of attack is very tiny. And if you look at the data, I mean, okay, it's encrypted with keys end to end, just like you would in a banking system. But if you were able to crack it, there's very limited data you can do, and you can't actually remote control it. Now, that's today. Maybe tomorrow, that might be different. But today, it's built to be super secure and nothing in the outside domain. And of course, if you then bring that system inside what we were talking about, like a virtual private network, then you've got a layer on a layer, and now you're probably as secure as the technology will allow you to be right here today.
Because 5G standard actually allows you to have a private network. So I can imagine at an airport, you would have a private 5G network that will be driving these buggies and those sort of things. That adds an extra layer of security because you can't get onto
It
that
does.
network.
Absolutely. So all of our airport applications are all 5G private network. So thinking about this, as you said earlier, from first principles, you've almost got to say, well, so for instance, to give you some data, currently at Heathrow at Terminal 5, they've got 850 baggage tug drivers. They've got 850 baggage dollies, and they've got about 350 tugs, some of which are diesel, a few are electric. So there's an environmental thing here to bring, an EV-based platform to airports. If you were to do that as our auto dolly, i.e. individual dollies doing the same job, you would bring 240 auto dollies to Terminal 5 to do the same job. And the staffing levels currently, even with all the things I've said, would be 90 people instead of 850 people. So 240 dollies, auto dollies, instead of 850 manual and 350 tugs to do the same job and to do it more efficiently. So it's a huge order of magnitude change to automate these airports. And what does that deliver? People in the audience might be thinking, well, hang on a second, nobody's going anywhere because COVID shut everything down. But the real problem for the airports is prior to COVID, everyone was trying to work out how they get more out of the operation because people wanted to fly, fly, fly. And if you take Heathrow, it's landlocked. You can't just keep building runways and buildings. So you've got to improve efficiency. And efficiency for turnaround of the time is really based on first bag and last bag. So how do you improve that going forward? And the biggest problem for the airline industry at the moment is probably by 2024 we'll be back up to pre-COVID travel levels, and they've laid a lot of people off. So do they bring all those people back while there's a crossover point for the technology? And so one of the things we've built to help them do that is a simulator. So we built a ground-up simulator that simulates an entire airport that allows you to tweak and turn the knobs, that allows you then to see what the airport would look like as it goes through that transition from manual through semi-automatic into fully automatic airport on the apron. And it's quite fascinating to see how that works. So we're working with a number of airports and airlines, literally simulating either a terminal or their entire airport to show them how they would operate in the future, and that is quite revealing. So yeah, some massive changes. And to round off your question, we targeted those areas because we think we can bring our systems and our technology quickly, and we can make a difference, whether it's people in passengers vehicles or whether it's efficiency in airports or logistics. And we let the big car companies put the billions of dollars into trying to do the cars on a freeway or a motorway.
So just a reminder to all our viewers that we've got under 10 minutes. So if you've got some burning questions, please put them in the chat. And a related question to what we just talked about with the reduction in need for humans, because you're automating this, one of the viewers has asked, technological unemployment is the process where jobs are lost when technology is invented that makes those jobs unnecessary, as you explained.
Yep.
This is an unstoppable part of technological process. The technologies you're developing would put a significant number of people out of work. What are your thoughts on how to give those people an income when their role has become obsolete?
Yeah, I think that is always a good question, because when technology has changed, I mean, if you go back to the printing press, or you go back to the, a weaving machine, what did it do? It put thousands, if not hundreds of thousands of people out of work. And I know myself, so I used to work for Rover Cars, and when Rover Cars went bust in 2004, although I'd got the company, at that time you got 3, maybe 4, maybe more than that, 1,000 people who were instantly displaced out of the automotive industry. Where did those people go? They were absorbed into other industries that were changing and growing, and they were retraining. And part of this process is we should never be frightened of change. I have never been frightened of change. And what change brings might be that you're displaced one set of people. But what we've got to do is we've got to get those people and we've got to retrain them and we've got to bring them into areas where there is growth in other areas. And that, to be honest with you, it's been going on for thousands of years. It will continue to go on for thousands of years. And that's all part of society and part of how we look at things. So I don't worry about changes in that respect. Even in my own company, I've brought computers in and machines downstairs that have mechanized areas that have displaced people. So things go on all the time where people are displaced. What we've got to do in society is we've got to have a really good mechanism to retrain those people and bring them into other areas that are on the ascendancy, and they need people in those areas.
So you touched on this a little bit, but from where you sit, what will the new normal look like for you and your clients in 2022 and beyond?
Well, I guess our technologies, as I've said, is getting better. Even as we're talking, there's a group of very intelligent people over here doing great work, and they've probably moved it on. So my 8-year-old is probably 8.5 while we've been talking. So that technology is moving rapidly, but it's moving rapidly in a safe way. So I think for our customers in our operational domains, the ones that I defined, low speed, nicely controlled and defined operational areas, I think what we're offering those customers is the ability to automate, revolutionize, save money, save time, deploy the capital that they're spending in a much better way. So all of those business things, because why would you do something if it doesn't have a business plan or a business mechanism behind it, and it doesn't deliver something that's got value? So what we aren't, we are not a company that is an R&D company that just makes bright, shiny things that look great but have no value. We're working on things that are going to add value. And I think that's the biggest things for our customers in the near term. Our products and technology will add value to what they're doing. And if we don't add value, we're not doing it right. And we need to go back to first principles and think about how we're going to add value. So it's quite exciting. It's an exciting world we live in. In fact, it's probably the most exciting. I look back in periods of time and I think, what are my famous periods of time? Victorian era, Roman era, Greek. Why? Because as an engineer, they were tremendous change periods where engineers were at the forefront of changing things and making things and just delivering things that people thought, wow, that's just amazing. And we are in that period now. This is one of those periods where people will look back and say, the engineers of that period, they were amazing. And that could be, by the way, just to finish off, that could be anything, autonomous vehicles, or that could be space flights. Who'd have thought we'd be putting humans up on a tourism in space? I mean, it's amazing times we live in.
So, final question. I'm a futurist. I've got to ask you this. What does the future of transportation look like? Is it autonomous flying cars?
I certainly think that will be an element. There'll be certainly an element. And then what you'll get lots of people with their own flying cars, and then suddenly you'll get a whole load of regulation that potentially stops you with your flying cars. Yes. And we've seen this in the drone industry. Of course, yes. No drones, then everybody's got a drone, then everyone's got a drone in the wrong area, and then legislation's coming in to maybe sort that out. But that is a typical industry that's gone from nothing to something. And actually, if we just discard the domestic, I've got my own drone and I'm flying it for pleasure, there are some fantastic drone applications that will benefit people. And so, yes, there will be flying cars. And will there be a flying car traffic jam in the sky? Probably, until legislation comes in.
So, David, I've learnt so much today. I'm sure our viewers have as well. How can we find out more about you and your company?
Well, you can go onto the website. So that's www.aurrigo.com. You can look me up on LinkedIn. I'm very happy to answer any questions. You can email me, dkeene@aurrigo.com. I'm very happy to talk to anybody, and very happy to have further discussions. So I hope that was interesting. I could bore your listeners to death for years, but as I say, it's exciting times. So do reach out if anybody wants to talk to me.
Well, what a great way to start our Spring Forward series. You've been a fantastic guest. Thank you so much. Thank you to Engineers Australia for their forward thinking in putting on this Spring Forward series. You can find out more about this series at engineersaustralia.org.au. You can find me at futurist.london, and have a great rest of the day or evening, and thanks for watching. Bye now.
Thank you. Bye-bye.